All equations we have talked about so far only have the variable appear in one place, but this won't always be the case. Sometimes the variable will be on both sides of the equation. Consider, for example, the equation 5x minus 1 equals 3x plus 9. With this kind of equation, the first step we have to do is to move all occurrences of the variable to the same side of the equation so that we can combine them. Here, we can subtract 3x from both sides to get 5x minus 1 minus 3x equals 3x plus 9 minus 3x. Now this is the same as 5x minus 3x minus 1 equals 3x minus 3x plus 9. The 3x's here cancel, and the 5x minus 3x just becomes 2x. Now we're left with 2x minus 1 equals 9. This is an equation that we're familiar with already, and we know how to solve. We can just add 1 to both sides to get 2x minus 1 plus 1 equals 9 plus 1, so that 2x equals 10 as the 1's cancel. Now dividing both sides by 2, we have 2x divided by 2 equals 10 divided by 2, and we're left with x equals 5. Sometimes you'll encounter equations which are more complicated and where it's not obvious how to move all occurrences of the variable to one side. For example, if we have 2 times y plus 2 equals 4 times y minus 1 minus 6. In this equation, the y's are in parentheses and cannot be easily subtracted from both sides. When this happens, we must first simplify the expression into something we can deal with more easily. Using the distributive property, we find that 2y plus 4 equals 4y minus 4 minus 6. Then combining the minus 4 with the minus 6, we have 2y plus 4 equals 4y minus 10. Just like before, we can now subtract 2y from both sides of the equation. We get 2y plus 4 minus 2y equals 4y minus 10 minus 2y. If we now combine the like terms, we see that 4 equals 2y minus 10, since the 2y's cancel on the left side, and on the right side, 4y minus 2y equals 2y. Now we can add 10 to both sides, so that 4 plus 10 equals 2y minus 10 plus 10. The 10's cancel on the right side, and we get 14 equals 2y. If we divide both sides by 2, we see that 14 over 2 equals 2y over 2. So y equals 7. Sometimes you will see equations where all values of the variable solve the equation. In this case, it is called an identity, or where no values solve the equation. For example, if we have 3n plus 1 equals 2 times n plus 3 plus n, and we try to solve this equation, we start by using the distributive property to simplify. 3n plus 1 equals 2n plus 6 plus n. Now notice on the right side, 2n plus n combines to give us 3n plus 1 equals 3n plus 6. Now, if we subtract 3n from both sides, we will have 3n plus 1 minus 3n equals 3n plus 6 minus 3n. but the three n's cancel on both sides of the equation, and we're left with 1 equals 6. Now this is clearly false. Since our original equation implies that this final result 1 equals 6 must be true, that means the original equation must be false no matter what n is. Now what if we modified the original equation a bit and replaced 1 on the left side with 6? In the second step, we would still have the 1 replaced by a 6, and the same all the way down. Now you can see that our final result is 6 equals 6, but this is always true. This means that our original equation must be true no matter what the value of n is. One of these special cases of either identity or no solution must occur if all of the values of the variable cancel.